Welcome back, friends. In this one, I'm going to explore the concept of where an extraneous solution might come from in a logarithmic equation. So I'm going to type log base 2 of x plus log base 2 of x minus 2 and set that equal to 3. What I want to do is just graph the two sides of the equation right now. So I know already by experience I need to zoom out a bit more so I can see more of it. And then I'm going to punch in the left side. So it's going to be log base 2 of x and then plus log base 2 of x minus 2. So that's the left side of it graphed. As you can see, it looks like that. Graph also the right side. That's just 3. And if you look at this graph very carefully, you see there's only one solution. That one solution occurs right there, right? If you look down to the x-axis, that's where the two graphs meet. That corresponds down there to a value of x equals positive 4. So now let's apply some log rules. On the left side, I'm going to type log base 2, bracket, and then x minus 2, and set that equal to 3. Apply the exponential form of the equation. That means 2 to the third will now be equal to the following. X times x minus 2. 2 to the third is 8. On the right hand side, x times x is x squared, and then x times negative 2 is negative 2x. Now we stop again, we focus on that step. That's a quadratic equation now. It's not a logarithmic equation. It's a quadratic equation that doesn't remember, in fact, that it came from a logarithmic equation. So look at the difference. Plot that side. In other words, this new form of the equation that has been given to us by the algebraic steps we've taken. So if I do that, look carefully. I'm going to plot 8 on one side, and I'm going to plot x squared minus 2x on the other side. At first, it doesn't seem like I can see them, but eventually, I just have to adjust my zoom level here. So let me do that right now. There we are. Now, something has happened that's different compared to the last one. The solution of x equals positive 4 is still present right here. That hasn't changed. However, a new solution has arisen right here, where it says x equals negative 2. That's a new solution. What I mean by that is, look on the graph on the left side, at negative 2 right here. It's true that the one that says 3, which is the green line, exists, right? But the log of base 2x plus log base 2 of x minus 2, that side never reaches over there because it's out of the domain of that side, you see? Whereas here, it comes from the fact that right now, this is just a quadratic equation that doesn't remember that it came from a logarithmic equation. The consequence is this extra solution right here has been introduced. Let's complete the process now of solving the quadratic equations. That would be the following. 0 on that side would be equal to x squared minus 2x and then minus 8. All right, on the right side, just factor it, so it's going to be the following. You need two numbers that multiply to negative 8, same two numbers add up to negative 2. Perhaps you know what they are, but it's going to be the following. X minus 4 and then x plus 2. Now we just set each of those pieces equal to 0 by the principle of zero products. So in other words, either x minus 4 is 0 or x plus 2 is equal to 0. Solve these. X is equal to 4 or x equals negative 2. I want to stress this right here. You see how at the very end we end up at this x equals negative 2? That is the result of it being a quadratic equation that's coming from here. That doesn't exist in the graph on the left side. And this is why, for example, when you begin with a logarithmic equation, you can end up with an extraneous solution. Please leave a like and subscribe, friends. Thank you. I'll see you in another video.